In the second part of lesson 2, we are going to talk about finding the area of regular polygons. And so when we talk about this, we're talking about a polygon that is equilateral, meaning all the sides are the same, and also equiangular. So regular polygon, we can have a pentagon, a hexagon, octagon, a heptagon, any of those. Well, we're going to think about taking our polygon and splitting it into triangles. So as you can see from the center, we have split this into 5 triangles because it is a pentagon. And these triangles are all going to be isosceles. Not only are these triangles isosceles, they are all congruent to each other. Now, a couple terms that they're going to use as we work through this lesson is they're going to refer to the central angle. This here is the central angle. It's the angle at the center. And if I look at my central angle, I actually would have 5 of them going all the way around the figure. So I could actually calculate my central angle by taking the 360 degrees all the way around and dividing by 5. The other thing that we're going to take a look at is this dotted line here. This dotted line is the height of my triangle, but it has a special name in these figures or in these polygons. This is going to be called the apothem. The apothem, well, it really is the height of the triangle. So how would we go about calculating the area? Okay, I've taken that figure and I've just enlarged it for us to make it a little bit easier. First of all, I'd want to think about an angle measure, and again, this is my central angle. I could calculate that central angle by taking 360 degrees and dividing by 5. There are 5 central angles that complete that rotation, and that would tell me that that central angle is 72 degrees. Now, as I take and I look at finding the area, if I find the area of one of my triangles, I say, well, I could simply multiply that by the number of triangles. And we know to find the area of a triangle is 1/2 base times height. 1/2 base times height. Well, the height of my triangle here is this dotted line, the apothem. Now, I'd have to be given at least one measure in order to work off of, or to work to find the area. So in this particular picture, I'm going to go ahead and tell you that the apothem we are going to think about as being 9 centimeters. Okay, so I'm going to label this 9. And if I take that triangle and it had a central angle of 72, my apothem is going to split it down the middle. I now have a 36 and 36. The reason that we're going to think about it splitting my angle is I'm actually going to use my right triangle here to do a little bit of calculating. If I'm going to find the area of my triangle, 1/2 base times height, I need to think about how I would find that base measure. Because I've split it for the right triangle, I could actually think about finding x using SOHCAHTOA, or using my trigonometry. If I take that 1/2 over here, this my apothem is 9, this angle is 36, we have a right triangle, we could use SOHCAHTOA. Well, this would happen to be my opposite side, this would be my adjacent side, and over here we would have the hypotenuse. So looking for x, it looks like I would use tangent. I could set that up to say that the tangent of 36 degrees is equal to the opposite over the adjacent. We would simply take tangent 36 and we would multiply by 9, and we would find out that our x value would be about 6.5. Now, as I find the area of my triangle, I'm not going to use 6.5 as my base. I actually am going to have to double that. And when I double that, I'm going to use a base of 13. So finding my area, well, my triangle would have an area of 1/2 the base times the height. That would be one triangle. But in this figure, I can see that I have 5 of those all the same, so I'm going to multiply that number by 5. 1/2 times 13 times 9 times 5. Now we have done a little bit of rounding here, so this is an approximation, but we're going to find out that our area is going to come out to about 585 centimeters squared. We're actually going to use this same strategy for all of our regular polygons, whether it be an octagon, a hexagon, a heptagon. We're going to divide it into triangles and find the area of one triangle multiplied by the number there are. So as you turn your paper over, at the top I have what I call the formula box, and I kind of like to write my formula this way. We're going to take the area of my triangle, and I'm going to multiply it by the number of triangles. We know then that that would mean we are really taking 1/2 base times height times our number of triangles. And the height of our triangle is what we said was our apothem. Now in the book, they're going to use a formula that they write as 1/2 times A times S times N, 1/2 ASN. The S is the side length, and the N is the number of sides. Well, that really is the area of the triangle times the number of triangles. Let's take a look at example B. In example B, the first figure, I'm finding my area. Well, the first thing I'm going to do is I'm going to think about dividing it up into my triangles. If I needed to find my area here, well, I actually have the apothem is 5/3, and the base of my triangle, well, I can see over here, that's actually given. My base is going to be 10. So I do not need to use any trig in this particular example. We can have 1/2 times the base times the height times the number of triangles. This particular figure is a hexagon, so there are 6 of them. Now I'm going to take it, I'm just going to multiply that on my calculator. But what I do want you to be careful of, when you enter 5/3 on your calculator, it's going to put a parenthesis right there. So you need to make sure that you close that parenthesis off, okay? So when you enter this in, you should find that your area is about 259.8. 259.8 units squared. If you forget to close that parenthesis, it's actually going to take the square root of 18, and that would end up with an answer of about 106.1. That is not correct. So you know that if that's what you get, you forgot to close your parenthesis here. Let's take a look at the second figure. The second figure, again, I'm going to think about dividing into my triangles. Well, this is one where all I'm really given is the height of my triangle is 5.1. So I'm going to have to do some figuring to find my base. What do I do first? Well, I have to think about my central angle. And my central angle here, well, there's 5 of those central angles, so I'm going to take 360 and divide by 5. And just like on the front side, we're going to find that's a 72-degree angle. When we add in the height, which is our apothem, it splits that, and I now have a 36-degree angle. So I could take and maybe enlarge that for us. We know that the apothem is 5.1. We're wanting to find the base, but in order for us to use our trig, we need our right triangle. So we're actually going to think about finding x. Here, I would have opposite and adjacent. So again, I could use my tangent function. the tangent of 36 degrees is going to be equal to opposite over adjacent. We would go ahead and we would just multiply. We would find that our x will come out to about 3.7. If x is about 3.7, that means that our total base of our triangle is going to be double that. So we times it by 2, and we'd find out it's about 7.4. So as I go to calculate my area, my triangle here, 1/2 base times height. Well, we have a base of 7.4, and I have a height of 5.1. How many triangles do I have? Well, it's a pentagon, so I have 5 of them. And I'm simply going to multiply everything together. Multiplying, we should find that we have about 94.35 or 94.35 square units. Let's look at figure 3. Figure 3. First thing I'm going to do is I'm going to split it into triangles. How is this one different? Well, number one, we have 7 triangles. So I have a heptagon here. And this time, I'm not given the apothem. I'm actually given the base of the triangle. I need to do some calculating so that I can find this apothem right here. So first thing, we need an angle to work off of. We're going to think about our central angle. We're going to take 360 degrees for our rotation, but this time we're actually going to divide by 7 because there are 7 central angles. Now it doesn't come out exact, so we're actually going to have to do a little bit of rounding, and we would find that we would get about 51.4 degrees. 51.4 degrees, my central angle. Now if I take that and I drop in my apothem, I've actually split that central angle in half. So I'm going to take and enlarge my triangle a little bit here. This angle is actually about 25.7 degrees because we've split the central angle in half. Now we know that this base is given as 3, which really means on my right triangle, this segment here is going to be 1.5. We need to figure out what our apothem is. Well, again, I can use SOHCAHTOA or my trig. I have opposite. This time I'm looking for adjacent. So when I set this up, it's just going to be slightly different. My opposite is 1.5. My adjacent is A. Now we know that if we were to cross multiply and solve, we'd actually end up taking 1.5 and divide by the tangent of 25.7. And we would find that we get about 3.1. What does that mean? That means my apothem, or the height of my triangle, is about 3.1. So if I go to calculate my area, 1/2 the base. Now I need the whole base of my triangle, so I'm going to use 3. The height is 3.1, and this time we have 7 of those because we have a heptagon. Multiplying through, we would find we get about 32.6 square centimeters. Figure 4. Same start as usual. We're going to divide into triangles. This time you'll notice my given information is actually the side of that triangle is 10. Now I need to do some calculating, and I'm going to need an angle measure. So if this is a 6-sided figure, I have 6 triangles. I'm going to take 360 and divide by 6. I am finding then that my central angle would be 60 degrees. As I take my triangle and I kind of enlarge it here, I'm going to drop in my apothem. It's going to split that so that that angle now is 30. My sides of my triangle were 10. That's actually going to give me the hypotenuse of that triangle. I'm really going to need to find two different measures. I'm going to need to find x so that I can find my base, and I'm going to need to find a, my apothem. We can continue to use SOHCAHTOA, but this time I'm not going to start out by using my tangent. If I'm going to find x first, I'm going to have to use 10, which is my hypotenuse. So I'm going to have the opposite and the hypotenuse. I'm actually going to have to use the sine ratio. The sine of 30 degrees would be opposite over hypotenuse. Multiply those together and we would find that we would get 5. Now to find A is adjacent. I still could use my hypotenuse. I could use cosine. And we would find that we would get about 8.7. What does that mean? Well, if x is 5, it means the whole base of my triangle is actually going to be 10. So when I go to find my area, 1/2 base times height times the number of triangles. And in the end, our area would be about 261 square inches. Okay, if you have further questions on this, please feel free to stop in